Hello, I am Iftikhar Din Ahmed and my metric number is A20EC3016.
Hello, my name is Tahia Khan and my metric number is 820EC3030.
Hello, I am Ayub Nabili and my metric number is 820 EC4054.
Hello, my name is Muhammad Abu Talha Ibn Riyad Hassan. My metric number is A20EC3022, and in this video we will be explaining how we solved Lab 3B. We will be showing how we build and debug our code, and after we are done with the lab demo, each of us are going to reflect on all the lab exercises.
So this is the first question for lab 3 where we need to use a loop to solve this equation. So first I'll save and build this project. So it's going to be successful and then I'm going to debug it. And I'll add the variables in the watch run.
Here we can see that in line 7, total is an identifier with 0 age value. And line 8, the number of times of the loop will iterate.
So to execute a loop instruction, we need to first store the number of iterations the loop will go through into the ECX register. In our case, we will store the counter D word, which has a value of 7 times, into the ECX register. So now that the ECX register is holding the number of iterations, we need to initiate the EAX register with the total number, which is 0 hexadecimal. As we see, EAX register is now holding the 0 value. The equation we want to solve is 100 hexadecimal times 7h. And as we know, the multiplication is a successive addition. So we will use a loop to keep adding 100h hexadecimal to AX register 7 times, which will be 100 plus 100 plus 100 7 times.
As we can see that this is our loop here at L1, and we will be adding 100H to EAX, and the loop will run 7 times because the value at register EAX is 7. So 100H will be added to register EAX, which currently is 0. So basically it will be 0 plus 100 plus 100, and we will keep on doing this 7 times because multiplication is also successive addition. So basically we are using a loop to add 100 to register EAX 7 times. So if we move forward, we can see that the value of EAX is increased by 100, and it keeps on increasing 7 times. The loop will run 7 times, and the value of registered EAX will eventually become 700. Now the value at register EAX is 700, so we will move out of the loop and we will move the value at EAX to the identifier total. So if we move forward, we can see that the total is now 708. So we can conclude that we have achieved 100 multiplied by 7.
So this is the second question for lab 3. We're going to first start by doing the division that's inside the brackets, and then we'll multiply the resultant value with d. We do the division first since the operation inside the brackets has a higher priority than the rest of the equation.
Now I am going to build and debug the code.
Since we are using Word, which is of 16 bits memory, our dividend will be stored in dxax. So dx is the higher value and ax is the lower value. First we will be clearing dx, so we will move 0 to register dx. um, as we can see over here, that is happening. Dx is equal to 0. We can change our hexadecimal display off so we can value it more clearly. And then we will move value b, which is 12, to register ax. Register ax will now become 12, as we can see right here. And then we will move our divisor, which is value c, to register cx. Register cx is here, and now register cx becomes 4. Now if we do div cx, that means we are doing this, 12 divided by 4. And when this happens, the quotient is stored in the ax, and the quotient is 3, and remainder, which is 0, is stored in the dx. If we step into the program, we can see that happening. So dx becomes 0, which is the remainder, and ax becomes 3, which is the quotient. And we can turn our hexadecimal display on.
So now we have to multiply the value stored at the AX register with 20. The value of AX now will be 3. So first what we'll be doing is move the variable d, which is holding the number 20, which is our multiplier in this case. We will move the variable d, which is 20, to the BX register, and then first here is the 20 in hexadecimal, and it is holding 20 in decimal number. After that we will be multiplying the value at bx with the value at ax, which will be in our case 3 times 20, which should give us 60. So as we see, it gave us 3c, which is the result of our equation in hexadecimal number, and it is 60 in decimal number. Then afterwards we move the value, the ax value, the result 16, to our value a.
So we learned a lot from this lab. Firstly, we learned how to do multiplication and division using assembly language. We also learned where the product is stored after a multiplication, and we also know where the quotient and the remainder is stored after doing a division. Overall, we learned how to solve equations using assembly language.
In part A, we learned about the flags that the ALU contains. We learned the functions of each of these flags and how they are affected and used by arithmetic. We learned about sign flag, zero flag, carry flag, overflow flag. We did 2 code tracing exercises and learned when the flags become set and when the flags become clear.
From this exercise, I learned a lot about loops and jumps in the assembly language. I learned how they work and how they can be used in an assembly program. I learned about the 2 types of jump statements. One is conditional jump and the other is unconditional jump. I learned how a loop executes a block of statements repeatedly. I also learned that the counter of a loop is stored in the register ECX.
This lab exercise also taught us about the offset operator and how we can use arrays to store multiple values of the same data type. I learned where the offset is located in a data segment, and I learned how the offset operator returns the address of a data. I also learned how to traverse an array. With all this said, we can conclude that we learned a lot from Lab 3, and we hope we can apply all this knowledge in our projects. Thank you for watching.